Have you ever wondered if there could be another you living a completely different life in a parallel universe? This tantalizing idea challenges our conventional understanding of reality, hinting at a cosmos far more complex and intriguing. Dive with us into the captivating world of parallel dimensions. To explore parallel dimensions, we must venture into the realm of theoretical physics. Here we encounter two mind-bending concepts: string theory and the multiverse. Let's start with string theory. Imagine, if you will, that the smallest particles in the universe are not actually particles at all. Instead, they are tiny, vibrating strings of energy. These strings vibrate at different frequencies, like the strings on a guitar, and these vibrations give rise to the particles we know, such as electrons and quarks. Now, here's where it gets interesting. String theory suggests that our universe may not just be a three-dimensional space, but consists of 10 dimensions. These extra dimensions are compactified or hidden from us, much like a tightly coiled string that appears as a point from a distance. Then we have the concept of the multiverse, akin to a cosmic quilt where each patchwork piece represents a separate universe with its own laws of physics. Our universe is just one patch on this infinite quilt. Each of these universes may have different dimensions, different types of matter, and even different laws of physics. But how does this relate to parallel dimensions? Well, if there are multiple universes, each with its own dimensions, then there could be universes that mirror our own, creating a parallel dimension. It's a lot to take in, isn't it? But here's a simpler way to think about it. Imagine you're reading a book. The story unfolds in a linear fashion from beginning to end. But what if each page of that book was a different universe and you could flip between them at will? That's the multiverse. And the string theory, that's the ink, the letters, the very building blocks that make up each page. These theories, while complex, provide the framework for understanding parallel dimensions. They enable us to ask bold questions about our universe, or should we say universes? And who knows, one day we might just find the answers we're seeking. Let's hear from the experts themselves. Our journey through the fascinating realm of parallel dimensions wouldn't be complete without hearing from the leading physicists and researchers pushing the boundaries of our understanding. From their labs, from their desks, and from their chalkboards, they're crafting theories and conducting experiments that just might change our perception of reality. Take Dr. Jane Goodwin, for example. She's at the forefront of string theory, leading her team in groundbreaking research. Her work involves complex mathematics and mind-bending concepts, but at its core, she's trying to answer one question: are there other dimensions hidden within the fabric of our universe? Then there's Professor Ahmed Patel, a theoretical physicist who has dedicated his career to the multiverse theory. He's not just pondering the existence of parallel dimensions, he's exploring the possibility that each dimension could house an entirely different universe. His experiments, that are though abstract and intricate, are aimed at finding traces of these parallel universes in our own. We also have Dr. Emily Chen, a young physicist making waves in the field. She's conducting experiments in quantum mechanics, a field that's often seen as the key to unlocking the mysteries of parallel dimensions. Her work revolves around the behavior of particles at the quantum level and how their seemingly impossible actions might be explained by the existence of parallel dimensions. Each of these scientists, in their own way, is contributing to the larger quest for understanding. Their work, their theories, and their experiments are all pieces of the puzzle. They're looking for signs, for hints, for any evidence that might suggest we're not alone in our universe, not in terms of extraterrestrial life, but in terms of dimensions, universes, realities. Their work is challenging, their paths often fraught with skepticism and doubt, but their determination, their curiosity, and their passion for discovery keep them going. They're not just exploring the universe, they're expanding our understanding of what the universe could be. As we can see, the scientific community is actively exploring the possibility of parallel dimensions. And what evidence do we have of these parallel dimensions, you might ask? Well, let's delve into the fascinating world of theoretical physics to find out. Firstly, let's consider the Large Hadron Collider, the world's largest and most powerful particle accelerator. Researchers here have been on the lookout for mini black holes, not your typical space-time devouring monsters, but tiny, almost microscopic versions. Their existence, as predicted by string theory, could imply the presence of extra dimensions. Then there's the curious case of dark matter. This elusive substance doesn't interact with light, making it invisible to our detectors. However, its gravitational effects on galaxies suggest it's there. Some scientists propose that dark matter might be in a parallel universe, only interacting with ours through gravity. Quantum mechanics, the rule book for particles smaller than an atom, also throws up some intriguing suggestions. Take the phenomenon of quantum entanglement, for example. It's where two particles, no matter how far apart, can instantaneously affect each other's state. Could they be interacting through an unseen parallel dimension? It's a tantalizing thought. And let's not forget about cosmic inflation, the theory that the universe expanded faster than the speed of light after the Big Bang. This could have given birth to a multiverse, a collection of universes, including ours, existing in parallel. Visualize it this way. Imagine you're on a boat in the middle of an ocean. You can only see so far, limited by your horizon. But that doesn't mean the ocean ends there. It continues hosting other boats, other horizons. Similarly, our observable universe may be just one of an infinite number of universes, each with its own laws of physics. Now, bear in mind that these are theories based on our current understanding of physics. They're not definitive proof, but rather intriguing hints at what could be out there, beyond our perception. And that's the beauty of science. It's a never-ending quest for knowledge, fueled by curiosity and wonder. As we continue to explore, to question, to probe the depths of the cosmos, who knows what we might discover? The evidence might be elusive, but it continues to captivate researchers around the globe. The quest for understanding parallel dimensions is far from over. As we continue our discussion with the leading physicists and researchers, we delve deeper into the challenges they face in their quest to unravel the mysteries of the multiverse. Dr. Lillian Hughes, a renowned theoretical physicist, shares, "The concept of parallel dimensions is so far removed from our everyday experiences that it is challenging to even conceive experiments that could provide definitive proof. We're essentially trying to detect something that by definition exists outside our perceivable universe." However, despite these challenges, the scientific community remains undeterred. They're driven by curiosity, a thirst for knowledge, and the tantalizing possibility of finding evidence that could fundamentally transform our understanding of reality. Dr. Alexander Cowrie, a leading researcher in string theory, explains, "In the future, we might look at cosmic microwave background radiation or the minute fluctuations in the cosmic gravitational field to detect the imprint of other universes. The experiments are extremely complex and require highly sensitive instruments, but the payoff could be monumental." Theoretical physicist Dr. Amelia Jensen adds, "There are also theoretical models that suggest the existence of wormholes or shortcuts through space-time that could potentially lead us to another universe. However, we're still a long way from being able to test these theories." The journey to uncover the mysteries of parallel dimensions is not a sprint, but a marathon. It's a painstaking process, but each step brings us closer to the answers we seek. As Dr. Hughes puts it, "The greatest breakthroughs in science often come from daring to venture into the unknown." And in our quest to understand parallel dimensions, we're doing precisely that. Indeed, the journey to uncover the mysteries of parallel dimensions is a challenging yet exciting one. It's a journey that pushes the boundaries of our knowledge, our imagination, and our understanding of the universe itself. And who knows, perhaps one day we might just find ourselves staring into the face of another universe, forever changing our perception of reality. What would it mean for us if parallel dimensions do exist? This is the question that has intrigued scientists, philosophers, and curious minds alike. As we delve into the implications of parallel dimensions, we find ourselves on the precipice of a paradigm shift, a complete reshaping of our understanding of reality. Imagine, if you will, a universe identical to ours, but with one slight difference. In this universe, you chose tea over coffee this morning, or perhaps another universe where dinosaurs never went extinct. The possibilities are infinite, each one more fascinating than the last. This concept is not just a feat of imagination, but a scientific possibility that exists within the framework of theoretical physics. The existence of parallel dimensions could influence how we perceive time and space. Time might not be linear, as we've always thought, but a vast sea of possibilities and outcomes. Space as well could be much more complex, with dimensions hidden from our perception. We might be sharing our existence with countless other realities, unbeknownst to us. But it's not just our understanding of the physical world that could be turned upside down. The implications of parallel universes extend to the philosophical and existential realms as well. If there are infinite versions of us, living out every possible life scenario, what does that say about our choices, our free will? Does it diminish our uniqueness, or does it elevate our existence to an unimaginable level of complexity? Moreover, it raises profound questions about life and death. If our consciousness exists in multiple dimensions, what happens when we die in one? Do we continue to exist in others? These questions might seem overwhelming, even unnerving, but they are the necessary byproduct of progress in our understanding. The existence of parallel dimensions could fundamentally change how we perceive ourselves and the universe. It's a concept that teeters on the edge of science and philosophy, intertwining the two in a dance of questions and possibilities. And as we continue this scientific journey, we inch closer to the answers, forever expanding the horizons of human knowledge and understanding. The exploration of parallel dimensions leaves us with profound questions. As we delve deeper into the mesmerizing realm of parallel dimensions, we're left with mysteries that border on the edge of comprehension. The very concept of parallel dimensions, of countless realities existing concurrently, is a puzzle that has both baffled and intrigued scientists and thinkers alike. One of the most gripping questions is, if parallel dimensions truly exist, why can't we perceive or interact with them? Our understanding of the universe is limited to a mere 4 dimensions, 3 of space and 1 of time. So, what if there are beings in other dimensions who can perceive dimensions beyond our comprehension, much like a being in a 2-dimensional world cannot perceive us in our 3-dimensional world? Another captivating question is, could we ever visit these parallel dimensions? Theoretical physics suggests that wormholes could serve as bridges between different dimensions. However, the creation and stabilization of these wormholes remain uncharted territories. Then there's the question of the multiverse. If there are infinite parallel dimensions, does it mean there's a version of you out there living an entirely different life? Could there be a dimension where the laws of physics as we know them simply do not apply? The concept of infinite possibilities can be both exhilarating and daunting. Lastly, what are the implications of parallel dimensions on our understanding of time? If each dimension represents a different possibility, could time travel be a reality in some other dimension? Could there be a dimension where time runs backwards? These questions are not just thought experiments, but they are critical to our understanding of the universe and our place in it. They push the boundaries of our knowledge and challenge us to rethink what we believe to be true. As we unravel the mysteries of the universe, we continue to uncover more questions than answers. The science of parallel dimensions is a fascinating journey that challenges our understanding of reality. We've journeyed through the complex maze of string theory, delved into multiverse concepts, and heard from the leading minds in theoretical physics. We've explored the compelling evidence that suggests the existence of parallel dimensions and pondered the profound implications these alternate realities may have on our perception of existence. The study of parallel dimensions is an intricate, awe-inspiring pursuit that continues to baffle and intrigue us. As we continue to peel back the layers of the universe, we are constantly reminded of how much we have yet to discover. As we continue to explore the fabric of reality, who knows what we might discover next? Perhaps one day we might even meet our parallel selves.